The Relationship Between Sleep and Memory by Don Anderson. According to Johns Hopkins Medicine, the brain controls our thoughts, our memories, emotion, motor skills, vision, breathing, temperature, hunger, and every other process that regulates our body. Like any other tool, the brain requires maintenance to help it reach maximum performance. There are several materials the brain requires to function properly. These include glucose, vitamins, minerals, and other essential chemicals. But there is much more that must be done to promote and enhance brain performance. One way this is achieved is through sleep. By resting, you allow the brain to rid itself of toxic waste and to store new information. When the body is asleep, your neurons or nerve cells reorganize. When you take a break, whether during sleep or just a resting period, there is increased activation of default mode network brain structures, including the medial temporal and medial frontal regions associated with memory processing. Even a short afternoon nap gives the brain the necessary opportunity to process new information and increases the chance of memory retention. This process is called transfer or consolidation. During any given night, a person's sleep contains multiple cycles that last from 45 to 90 minutes. These cycles have distinct phases of different brain activity. First, a person transitions from wakefulness to non-rapid eye movement. This is a light sleep and are stages 1 and 2. This is followed by a deep sleep known as slow wave sleep and is stage 3. Following this stage and before the cycle of sleep is complete, there is a return to light sleep, followed by REM, or rapid eye movement. It is during stage 3, a person's deep sleep, that heavy interaction between the hippocampus and neocortex takes place, helping to transfer new learning and consolidate memories. The importance of sleep is relevant for all ages. But sleep regulation undergoes a rapid change from infancy into adolescence. From pre-puberty on, the decrease in slow wave sleep throughout adolescence may reflect developmental alterations on the brain rather than significant matured sleep regulatory processes. Sleep is most crucial during early brain development up to the age of 2 years old. This developmental sleep is crucial to brain plasticity. During this time, a child is asleep more than 50% in a 24-hour day. As they grow, the amount of sleep required to function at maximum effectiveness decreases, and by the time a child reaches adolescence, they're making the choice to sleep less than the recommended 9 to 10 hours per day. Sleep deprivation is a significant problem, particularly among school-age children that have the weight of social and academic demands that require a majority of their time. With this lack of sleep comes a negative impact for these students. The result of trading much needed sleep for an extra hour of technology or completion of a lengthy homework assignment can lead to poor academic achievement, anxiety, depression, irritability, mood changes, impaired memory, hyperactivity, aggression, and even increased drug and alcohol use. Educators find themselves asking, how can they help with this issue? You can help by encouraging your students to have healthy sleep habits and go to bed at an earlier time. You can educate not only your students, but also their parents on the effects of sleep and learning. Be aware of reasons that students may not have gotten enough sleep, such as a holiday the day before. You can educate yourself on personal situations that your students may have that are affecting their sleep patterns. In the younger grades, you can encourage your students to take small breaks. You can focus on social emotional learning, and you can advocate with your administrator for a later start time. Sleep should be considered a positive time to rest and relax, and it should be considered a fundamental part of a child's life.